This is question 6 on chemistry from section 2 of the 2020 BMAT. So we're given this equation which describes a reaction between sodium hydroxide and chlorine to give sodium chloride, this sodium chlorine oxygen salt, and some water. Then we're asked which of these three statements are correct. So the first one says that chlorine has a +5 oxidation state in this compound. 2, that this is an example of a disproportionation reaction. And 3, that some of the oxygen in sodium hydroxide is oxidized in this reaction. So where to begin? Well, all of these statements relate in some way to the oxidation states that are going on in this reaction. So maybe it will be a good start and a good practice to quickly label the oxidation states of the elements in this reaction. So starting with sodium, what do we know about the oxidation states that sodium takes? So we know sodium exclusively takes the +1 oxidation state, being a group 1 atom, when it's in compounds. So in sodium hydroxide, we know it is +1, and the same story in sodium chloride and this compound. Then what about the hydrogen? So similarly, hydrogen always takes the +1 oxidation state, being a group 1 element, except when it's in a hydride. None of these compounds are hydrides, so we're okay to label all of these hydrogens as +1. Then what about oxygen? So we know the rule for oxygen is that it always takes a +2 oxidation state in a compound, unless the compound is some sort of peroxide. Now, none of these are peroxides, so we can safely label each of these oxygens as -2. Then that leaves us to work out chlorine. So in these Cl2 molecules, the oxidation state of chlorine is 0, because this is an element. Then what about in sodium chloride? So by subtraction, we can see that to make 0 overall, this has to be -1. In this compound, we need to do a bit of maths. So we have +1 from the sodium, with -2 from the oxygen 3 times, which takes us down to -5, and therefore the chlorine must be +5. So we've labelled all of our oxidation states. So now let's have another look at our statements. So statement 1 simply asks if chlorine has a +5 oxidation state in this compound, and from what we've already done, we can safely say that it does, because we've used our oxidation state rules and done the calculation to work out what's missing, which was chlorine, and so we know that the statement 1 has to be correct. Then what about statement 2? So firstly, what is a disproportionation reaction? So this is a reaction where we have some element E with some oxidation state X, just generally, and this forms two different compounds where this element E has two different oxidation states, one of them where it has increased and one where it has decreased. So in other words, in a disproportionation reaction, the element splits up into two different compounds where it has different oxidation states. So is this happening here? Well, we can see that the only element whose oxidation state changes is chlorine, and this goes from 0 to -1 and +5. And so this indeed satisfies this requirement that it has an oxidation state that simultaneously decreases and increases. So this is definitely an example of a disproportionation reaction. Then what about our final statement? Is some of the oxygen oxidized in this reaction? Well, no. We already said that oxygen remains in the -2 oxidation state, which it usually occupies, in all three of the compounds where it turns up. So we've already worked out that none of the oxygen is oxidized in this reaction. So we've been nice and thorough by labelling all of our oxidation states, and so we can be confident including that the statements that are correct are 1 and 2. So this corresponds to an answer of E.